So Dr. Bhattacharya, welcome to you, and it's our pleasure to have you, sir. So may I now ask you to kindly make your deliberation, sir. Over to you, sir.
Okay. Thank you very much, Doctor. Okay. So I'm first of all very thankful to Mr. Harish Murthy and the esteemed and learned and revered um, um, doctors who have given me this opportunity of talking about use of artificial intelligence in medicine, disease management. The overall umbrella would be healthcare. And we trust our lives with you, doctors, and we bring in technology and hope that some of these technological advancements would be of help to you. Now, I would like to focus on our ongoing and recent work on diagnosis assistance and adverse drug reaction detection, just to be able to take concrete examples of how AI is indeed helping in this particular domain. Now, my area is natural language processing. A lot of machine learning is used there, so I specialize in these two areas. Now, artificial intelligence has been used for healthcare in problems like early prediction, where clinical features are fed to a machine learning algorithm, and that is capable of early prediction of, let's say, cancer, for example. Now, remote diagnosis, where facilities are not available easily in remote parts of the country, parts of the world even, where image processing, computer vision, machine learning techniques have been deployed for diagnosis of maladies. One thing we have seen, which is very beneficial, is in the area of report generation. This particular problem is probably not given enough attention that it deserves, because a huge amount of time of doctors, radiologists, and many others are spent in generating the report of the patient. So if that part of the operation is made more efficient, then we reduce the time for these experts, and that time is more gainfully employed for more complex tasks. Adverse drug reaction we have found to be very important. It was brought to our notice by a startup in Silicon Valley, and we have worked on this. And bioinformatics in general is full of tasks which require natural language processing, machine learning, computer vision, and speech inputs. Now, artificial intelligence is a sub-area of computer science which addresses problems like robotics, language understanding, planning, which is used for navigating a robot, expert systems that actually can be marked very carefully, because this is what brought artificial intelligence close to medicine. In 70s, there was a system called MySyn, which was supposed to be an assistant for doing diagnosis for the doctors. And computer vision is also, of course, used quite a lot. Now, all these areas of artificial intelligence which impact our lives and are doing so increasingly, actually receive their foundational techniques from search algorithms, reasoning based on logic, and machine learning. Now, I'll take up a problem which we have been working on for last about 3 years, which uses machine learning, natural language processing, and speech technology for capability augmentation in radiology report generation. So this is a joint project between IIT Bombay and a company called ScribeTech, who are deeply into medical technology problems. And this is part of my Abdul Kalam Fellowship project, which insists on translational research. Now, the problem statement is as follows. Create a radiology report automatically, where the Input is diagnosis in spoken informal form. So the radiologist looks at the plate and dictates the diagnosis. The output is a correct pathological description. So the spoken form could be informal because this kind of statement has been made so many times that filling in further details is almost a routine task. So this is what we sort of exploit and make use of data and machine learning to fill in the details, fill in the gaps, you can say, to output a pathological description. And the challenge here is that the radiologists dictate to secretaries in their own style. There is variation of sentence, vocabulary, phrase, and so on. And a basic template is adapted to each situation. So radiology reports are of various kinds. I do not really want to preach to the choir. MRI, X-ray, ultrasound, CT for different parts of the body. Now, the motivation for this problem, which actually, brought the Abdul Kalam Fellowship, which is a prestigious fellowship. India is a country with 1.3 billion people and one radiologist per 100,000 population, and this hardly compares with with the situations prevailing in USA, which sees a ratio of 1:10,000, and China is 1:about 15,000. Though PACs and RISs have been installed in hospitals, they are still proving to be inadequate compared to the demand on the radiologist's time. Now, the stages in radiology report generation are the following. There is this dictation, which goes through a transcription stage, and that goes through correction. Correction and transcription can cycle, and finally, the corrected and refined report is produced, which is given to the patient. Now, radiologists typically dictate a report looking at the X-ray plate, which is shown here, and we apply natural language processing and speech technology to produce a very formal and detailed report. Now, the template report is of this form. This is our template report, which we have adopted from amongst many other options. So liver is normal in size and ecotexture show no focal areas of altered ecotexture or mass lesion. No intrahepatic biliary radicals dilation seen. Portal vein appears normal. So this is full of technical terms, but this is the template which we alter, just to draw your attention, which we alter for patient-specific situations. And of course, there are lots of variations on these descriptions. You can see liver normal in size and parenchymal ecotexture, no obvious focal or diffuse lesion is seen. So it is the same thing said in a different way. So this is how language operates. We say the same thing in many different ways, depending on the situation and making the communication more interesting and more varied. Now, the problem really is to convert the spoken form into pathological description. Things like liver mild increase in parenchymal echogenicity is converted to mild diffuse increase in hepatic echogenicity, which we have been told by the doctors to be more accurate and more formal. Of course, there are examples of very long pathological descriptions which are really detailed. Now, the approach we have taken is, here I'm being little technical, we create what is called the knowledge graph. So knowledge graph has parts, state, and properties. To give you an example, this is the knowledge graph of a liver. So liver has parts, state is trauma, for example, here, and there are properties. So this is created by a detailed interaction with the doctors who are very kind to sit with computer scientists, my students, my research associates, and also from the company, and give a structure of this kind. So we take this structure and make it more computationally amenable. Here the picture is in the form of what is called a tree, okay, which computer scientists are very familiar with. And then this tree is navigated with an algorithm to produce the proper pathological description. Now, the challenge that we face here is there is ambiguity. All sentences have ambiguity. I'll make more remarks on this as we go forward. So what happens is that many different parts of the knowledge graph get activated. Okay, many paths get activated, and therefore we have to do what is called a path ranking algorithm. I apologize for making some technical terms here, but they come in the flow sort of. So they essentially score the various pathological descriptions, give them a merit, figure of merit, and the one which is the best is output finally. So this has proven to be very useful. I give a case study. A doctor spoken from his hyperechoic lesion is found in left lobe measuring 10 into 15 centimeter. The output pathological description is well-defined hyperechoic lesion on the left lobe measuring 10 into 15 centimeter. Now, of course, there can be debate on whether the second form is more formal, more technical, more detailed than the first form, but I can show you examples where the spoken form is very informal, very short in length, but the pathological description elaborates it much further to be used by doctors downstream. Now, the ongoing work is we are creating knowledge graph for approximately 40 abdominal organs from existing reports and data sets. There are about 200,000 such reports and data sets, which we process and absorb and then apply machine learning on them. And we find out missing information from the current knowledge graph with the help of domain experts. Now, this brings me to the technology which we employ in such cases, technology of natural language processing and machine learning. I was tempted to tell you a very small story, maybe in 1 minute. This is called the story of the Tower of Babel. So what happened was that human beings decided to conquer the heaven. They started building a big tower to reach the heavens. But then gods became afraid. So what they did was they created many languages. And that languages brought communication barrier between people. And when people cannot communicate, they cannot work on a joint project. So the project failed. So this story is completely mythological and also metaphorical. This just shows that natural language processing is a challenging problem, but a critical one because you have to cross the communication barrier. So this is the art, science, and technique of making computers understand and generate language. It has been in existence since 1960s. It was born with computer science almost. Now, a typical practical situation would be customers complain about, let's say, an insurance company service, and the volume is so much that you need automation. So you need natural language understanding, automatic speech recognition, and sentiment, robots who will process this information and escalate the complaints to the higher management. Now, the problem with NLP is that there is ambiguity everywhere. So there was this Times of India headline recently, elderly with young face higher COVID-19 risk. If you do not give the pause at the right place, it can lead to very strange meaning. Elderly with young face higher COVID-19 risk. So old people who are living with young people face higher COVID-19 risk. So is young a noun or an adjective? Is face a verb or a noun? Depending on that, the meaning changes. Then why one should never date a tennis player? Because love means nothing to them. So there is this ambiguity of love and nothing, and literally it is correct because love is zero score, but it has a very colorful way of describing the situation. Then this is a very interesting problem again from NLP. Maharashtra reports increased COVID-19 cases. So Maharashtra reports increased COVID-19 cases, but suppose reports was looked upon as a noun, and increase is the main verb. Then Maharashtra reports increased COVID-19 cases, as if due to Maharashtra reports, the COVID-19 cases increased. And I'm not really, constructing these examples. They actually happen in computer when we feed language data to the machine. Then you can have what is called pragmatic ambiguity. The passenger says, "Thank you for sending me to Delhi and my luggage to Mumbai. Brilliant service." So this is a sarcastic statement, as you can see from the facial expression of the lady. And if the chatbot thanks the lady for this appreciation, then the lady's anger will increase further. So these are the challenges, and it happens in a layered manner, going from morphology, that is the words, up to large pieces of text where the meaning has to be understood. Now, deep neural networks have come into the field. They are doing pretty well on natural language processing also. So if you take a sentence like, "No dogs, please," "No dogs, please," then dogs are welcome. "No dogs, please," then this is the opposite meaning. Dogs are not welcome. So these kind of layered processing in a deep neural network can handle this kind of ambiguity quite a lot. And ambiguity is present in medical reports. They are rife. Medical reports are rife with ambiguity. We have seen it again and again over many years. Machine learning is the technology which is used here, and from table lookup you go up to deep neural networks. There the machine learning system becomes more and more robust, but it sacrifices explainability. In a deep neural network, we do not understand what is going on, why is the decision being taken the way the neural network is doing the way it is, and explainability is very important in healthcare. The automatic system will not be trusted unless it explains why it took a particular decision. So we have undertaken quite a lot of research in explainability. Maybe talk about it and some other point of time. So natural language processing is divided into many important areas. Many of you might have used machine translation. We do information search all the time, that is information retrieval, question answering. A patient's questions can be answered by a chatbot, saving the doctor a lot of time. So those kind of problems are very practical and very useful coming from natural language processing. Now, all our NLP work happens in the Center for Indian Language Technology, which is a 20 years old lab in IIT Bombay. Now, I'll end with another small example of application which we have been investigating. A master student of mine worked on this. This is the information extraction for pharmacovigilance problem. So pharmacovigilance is concerned with monitoring the safety of a drug by identifying adverse drug events and associated with it during clinical trials as well as post its approval. Now here the problems are delayed under-reporting, reports written in natural language, poor documentation, non-standard terminology, medication standardization. And a lot is at stake if we do not solve the pharmacovigilance problem. Costs $75 billion for USA, reported in USA. Complete drug ADR profile is unknown during approval, top 10 leading causes of death. Okay, but we can make use of the social media platform about what people are writing about a particular drug and apply NLP and machine learning for this. So an example would be this: the doctor prescribed linaclotide for constipation. I have stomach pain due to linaclotide. So here the association is between constipation, stomach pain, and linaclotide, and the entity linaclotide has to be extracted. The phrase like stomach pain, constipation, they also have to be extracted. And then we find a structure emerging where the adverse drug effect from linaclotide is stomach pain. Treatment caused by linaclotide is constipation. So we have to carefully isolate the adverse drug reaction from the beneficial treatment which comes from the drug. So this again is a machine learning task. We have to build a classifier called ADE classifier, and we have to use natural language processing to extract these ADE mentions. For example, it was explained to me that Humira will take care of arthritis. I had severe joint pain on Humira. So Humira is the drug, arthritis is the positive treatment event, and joint pain is the adverse event. So this we are able to do, we are able to partially, and quite a lot of success has been obtained on this, where you used machine learning, dictionary matching, social media posts have been processed, domain adaptation has been done. Now, end-to-end adverse drug extraction system has been built by us, which takes an input like Actos helped me to lower my blood sugar levels. I am happy that my doctor prescribed it to me. Notice that this it refers to Actos and not blood sugar level, for example. So there is a problem of pronoun to noun binding, which is an NLP problem. It is causing me restlessness. I did not experience any dizziness on it. So output mentions are Actos, blood sugar levels, severe restlessness, and dizziness. And the output relations are treatment relation between Actos and blood sugar level. And the ADE, adverse drug reaction, is severe restlessness. So we have built a tool for this, and we have taken it to the doctors, and two doctors' statements I'm reporting here. They have said that 100% working tool for potential adverse drug event reporting, which is currently being done manually by the majority of hospitals. So this is a 100% working tool by a doctor from Hiranandani Hospital, which is close to IIT Bombay. Another doctor has said very effective and practical tool for adverse events detection, and it is not storing any data related to patients or any other inputs, which is again very important for maintaining confidentiality and data propriety. So summary of my presentation, we have shortage of time. Capability augmentation in radiology report generation. We have got quite a lot of success in working on this problem. This this is being used in quite a few hospitals in Bombay. The nature of NLP and machine learning was described. I talked about the ambiguity problem and how machine learning chooses the right option amongst ambiguities. And pharmacovigilance is an important problem which we have been working on for last about 3 years. Conclusion and future work: immense scope for AI to step in and serve as assistant. I have active collaboration with Fresh Gravity, Shipe, and EasyDI and many others in AI and healthcare domain. These are the companies. Data holds the key. So we really need to train a machine with a lot of data. The more accurate are the decisions. And the technique is primarily now deep learning with a lot of linguistics, cognitive science, and even physics inputs coming into the algorithm. Thank you very much. And everything I said is in the form of publications linked from my homepage. We have also made a lot of data and resources and tools available from our lab homepage. Thank you very much for your attention.